Calculating the equilibrium constant. Problem 2. The equation represents three gases in equilibrium, 2A gas plus B gas, reacting reversibly, giving 2C gas, delta H less than 0. An unknown amount of three gases is taken in reaction vessel at a certain temperature, and the equilibrium mixture was found to contain 0,8 mole of A gas, 0,67 mole of B gas, and 0,53 mole of C gas. The volume of the reaction vessel is 4 decimeter cube. The temperature is increased and the reaction allowed to reach equilibrium again at the increased temperature. The equilibrium mixture now contains 0,4 mole of C gas. Calculate the equilibrium constant for the reaction at the second temperature. Solution. We are given the number of moles of the reactants and the product at the first equilibrium. Further, we are given the number of moles of the product at the second equilibrium. We are also given the volume of the vessel, 4 decimeter cube. We are not required to find the equilibrium constant at the first temperature when equilibrium is achieved, but rather the equilibrium constant when the temperature is increased and the mixture reaches equilibrium. To calculate the Kc value at the second temperature, we need to determine the equilibrium concentration of the reactants and the products at this temperature. We first need to find the number of moles of each of the species at the second equilibrium. Note that the number of moles at the first equilibrium is the initial number of moles of the reactants and products. We shall use this information. The number of moles of the product C, gas, at equilibrium is given. The change in the number of moles of C can be found. 0,40 mole minus 0,53 mole equals negative 0,13 mole. The negative sign indicates that the amount of C has decreased at the second temperature. From the reaction, the ratio of the number of moles of the reactants to the products is 2 to 1 to 2. Therefore, the change in the number of moles of the reactants will be in this ratio. The equilibrium amount of substance of the reactants can be found. Note here that the amount of substance of the reactants increases. To find the molar concentration, we divide the amount of substance by the volume of the vessel in decimeter cube. The concentration of A is 0,23 molar, the concentration of B is 0,18 molar, and the concentration of C is 0,1 molar. The equilibrium constant for the reaction can be written as Kc equals concentration of C square over concentration of A square times concentration of B. Substituting the values, Kc equals 1,05.
Starting to feel it? Now go master it with Maski.